Alright, in this tutorial I'm going to show you how you could get the CUDA software development kit and the libraries and the drivers that you need to be able to perform the parallel processing programs that we will be using in the parallel processing course. The first thing I will show you is how you will be able to figure out what is the hardware technology and hardware support that you need. If you have a laptop and you don't have a CUDA capable graphics card, then it's a pretty difficult situation because it's kind of hard, if not impossible actually, to upgrade your graphics card to a CUDA capable graphics processing unit. But if you do have a desktop, it's much easier, and in fact it's not really that expensive to acquire a CUDA capable graphics card so that you will be able to write your CUDA programs. Now, CUDA is a technology, a parallel processing, parallel computing platform, and a programming model that NVIDIA had invented, and it is an interesting technology and platform. And we will be focusing on the CUDA parallel processing for our programming applications because it's relatively inexpensive to acquire and to accelerate your programs and applications on a GPU CUDA platform, as opposed to going full-blown supercomputing. And the technology is different than essentially multi-threading and multi-core processing that general central processing units or CPUs will afford. So let's first talk about the website where you can get your information about CUDA. If you go on the nvidia.com and just search for CUDA on the NVIDIA website, you'll be able to get to the page, or you go to NVIDIA Home and Technologies and then CUDA Parallel Computing Platform. You'll be able to get to this page, and on this page you'll be able to click on the Go to CUDA zone to go to essentially the software developers zone, where you can get a lot of support. Before we do that, actually let's go to the CUDA zone. And in the CUDA zone, NVIDIA's software developer zone, you'll be able to learn about CUDA. We'll talk about it in the class, and see certain applications that are used basically, or that use CUDA. Now, on the quick links on the CUDA developer zone, you will be able to see two links: CUDA downloads and CUDA GPUs. And what we will be interested in is essentially the second link, to learn about whether our graphics card is CUDA capable or not. If not, what graphics card we should be acquiring to be able to perform the programming modules. And don't worry about if your graphics card is not CUDA capable and that you will not be able to get a CUDA capable graphics cards. The computer labs in Victoria and Sugar Land, two of the computer labs, one in Sugar Land and one in Victoria, have been already upgraded to CUDA capable graphics cards, and the software development kit is supposed to be installed on those labs. So if you don't have access to a CUDA graphics card on your machines and you need to perform the programming assignments, you'll be able to utilize the labs in Sugar Land and in Victoria, depending on where it's more convenient to you to access the labs to be able to perform your programming assignments. So let's click on CUDA GPUs. Then you click on CUDA GPUs, it'll take you to a list of all the GPUs that are available out there that are capable of CUDA, and next to each GPU it shows the compute capability. And we'll talk about compute capability of CUDA is essentially the revisions on the hardware that has been released. The latest compute capability is 3.5, which is supported by GeForce GTX 780 and GeForce GTX Titan. And I'm not expecting many students actually having these hardware platforms. So there are the CUDA-capable workstation products along the line of Tesla workstations and Tesla data centers. And so as you can see, the most recent one is Tesla K20, which supports the compute capability 3.5. And the very early on Teslas, Tesla D870 and Tesla S870, they had the compute capability 1.0. If you have Quattro graphic cards, NVIDIA graphic cards, the list of Quattro cards that support CUDA are here. And if you click on them, you'll be able to go into the page of that graphics cards, and then you'll be able to study their specifications, buy them if you need to, and download drivers and other components for these graphics cards. Also, there are the GeForce series of graphics cards that are CUDA capable, and as I said, the most advanced ones are GeForce GTX Titan, which support 3.5 capability, and GeForce GTX 780. And if you have desktops or laptops, you'll see them side by side. Each of the card will also have a laptop or a mobile version, and the list goes on and on. So one quick note, if you're on a short budget, you don't have a CUDA-capable graphics cards, and you do need to acquire one to install to be able to actually work with, and I do recommend getting a CUDA-capable graphics cards, because CUDA programming is fantastic, and you'll be able to do a lot of interesting things and learn a lot about CUDA. You might want to go on the GT series and pick something like GeForce GT440 or GeForce GT620. So for example, if you go to GeForce GT440, it'll take you to the link, and then when you click on buy, it'll show you that, for example, for 65 to about $75, you'll be able to purchase a GT440, which does support CUDA, and if you go to the specifications, you'll be able to see that it actually has 96 CUDA cores, and its graphics clock is about 810, which is not really huge, but it also has about half a gig or 1 gig of DDR3 or GDDR5 memory, graphics memory, and it requires a 300 watt power supply, which most PC cases, most desktop cases actually do have that kind of power supply. If you just keep going up on the list, you'll see, for example, GT460, which is actually took me to the GTX series. So you'd basically want to stick with the GT series, because those series don't require additional power supply connections, and usually for older computers they still work. If you are actually at the point that you're contemplating about upgrading your graphics cards, this might be a good time to do a little study on NVIDIA graphics cards and go and purchase one reasonably good graphics card. Another card that you might want to look at is a GeForce GT620. Again, the price should be kind of comparable. It's about $50, the 620, and the specifications on 620. Again, you see 96 CUDA cores. You've got about 1 gigabyte of RAM, and also a 300-watt power supply is plenty for this graphics card. Now, if you do have one of the CUDA-capable graphics cards, NVIDIA cards, or you decided to go about and purchase one and install, when you install the graphics cards and install all the updated drivers, then you will be able to go back to the CUDA developer zone, and there you'll go to CUDA downloads, and then you will be able to download the SDK. The SDK will give you a CUDA toolkit, code samples, and Insight Visual Studio for Windows, or for Eclipse for that matter, depending on which SDK you decide to install. And it will install all these tools on your computer, so that you'll be able to use Visual Studio to write C++ or to write Java programs that are tapping into and using your CUDA programming platform. And it'll give you all the libraries that you need. As a part of CUDA 5.5, you will get a host of a lot of additional libraries, such as BLAST, basic linear algebra, Thrust, which is a standard template library version for your CUDA programs, and a bunch of other very nice toolkits and software development kits and libraries that will come with your CUDA 5.5 installation. So to get the version that's appropriate to your platform, choose your operating system, Linux, Windows, or Mac operating system, and then decide what version of your operating system, you have, and the architecture of your computer. Hardware software combination, 32-bit or 64-bit. And then when you decide on the appropriate platform, and of course the SDKs for Windows are different from notebook and desktop applications, click on the appropriate one and then save the installation file, and it will go in and save it on a location on your machine. So once you downloaded the CUDA SDK and toolkit, double click on the executable file and just follow the instructions. It will update your graphics drivers if need to be, and also it will go ahead and install the SDK and the libraries that you need to be able to use and to write CUDA programs in Visual Studio 2010 and 2012 under both Windows 7 and Windows 8. So once you're done installing, I would like you to go ahead and test your platform and see if it works. And I'm going to basically use Visual Studio 2010, and but you can basically use Visual Studio 2012. I do recommend for the programs to stick with 2010 Visual Studio edition, because I'm using Visual Studio 2010 for grading. So for the uniformity of the class, let's all use Visual Studio 2010. Now, I'm going to create a new project, and here's the project that we left off with OpenCV. So go ahead and click on New and then click on Project. Now in the Project Wizard, after you've installed your CUDA toolkit, you'll see that there is going to be a template called NVIDIA. And when you expand the NVIDIA, you'll be able to see CUDA 5.5 runtime. And then click on CUDA 5.5 runtime and create a project. Since I have my project in separate folders, for the purpose of this program, I want the projects to be in CUDA. So I'm going to right click and create a new folder for my solutions that deal with CUDA programs, and then I call it CUDA projects. I select that folder as my destination, and then I call it CUDA test 01, which will be my first project in CUDA. When you finish the project setup, you will notice that your Visual Studio will basically create a project, and it will create a bunch of dependencies, external dependencies, that are the files and libraries that are needed from your CUDA toolkit, and then it's going to create your main file, and it is going to call it kernel.cu, and that stands for CUDA. If everything has installed properly, you should not see any red wiggly lines indicating any kind of error, and also your program should work. So to do that, I'm going to compile this program, and after compiling this program, hopefully I will not get any compile error indicating that my program had successfully compiled, and indeed it did successfully compile, and then I'm going to run this program. And what you should see with this simple basic CUDA project is you should see that I have two arrays, 5 item long each. The first one is 1, 2, 3, 4, 5. The second one is 10, 20, 30, 40, 50, and I'm summing these up. And it's going to create another 5-dimensional 5-unit array, and it's going to have the sum of the first elements, the sum of the second elements, the sum of the third elements, and so forth, till the fifth elements. This is a very simple example to show that your program works. If anything goes wrong with your installation, if you don't have a CUDA capable graphics card, or the SDK is not installed properly, you're going to get an error. Otherwise, you should be good to go. I'm going to just go over really quickly over what is involved with this program, but we're going to learn about writing these programs ourselves. Basically, as you see, the device launch parameters and runtime CUDA have been included. The standard I/O header is also included. Then a kernel function is created, and this function is the function that's going to run on CUDA. And each core is going to initiate a bunch of threads, and each thread will take in a data that is copied into your GPU memory by a process of transferring CPU memory to GPU, data from CPU memory to GPU, then runs a simple process, basically adding 2 units per thread and saving the resulting unit into your GPU unit. This kernel is what we essentially invoke on our CPU that will handle the processing on the GPU side. And as you see, the global directive, the global prefix, is what indicates this function as a graphics processing function that will run in the graphics processing unit. The rest of this process, this function is actually the main body of this function is fairly straightforward. It's just like every C++ file. It's an int main function. I have 3 arrays, array A, B, and C. And as you see, array A is initialized with 1, 2, 3, 4, 5, and B is initialized with 10, 20, 30, 40, 50, and C is initialized as just starting with 5 zeros. Then I'm going to check to see if add with CUDA function that will initialize basically the 3 memory allocations that I have, A, B, and C as arrays. If that function basically performs and operates. And what happens in the add with CUDA function, which is down here, I'm going to create 3 pointers that will point to memory locations on my GPU memory units, basically 3 pointers, and then I'm going to associate first, to get the device number, if I have a GPU that is CUDA capable, the CUDA get device number will return the ID of that CUDA graphics card. And if it's successful, that shows that I succeeded and I had a CUDA capable graphics card. If it does not succeed, if I don't have a graphics card that's CUDA capable, this operation on line 51 will fail, and therefore I can print out that your device failed because you don't have a CUDA capable graphics card. Next, I'm going to allocate for the device pointer C, device pointer B, device pointer A. I'm going to allocate enough memory locations on my graphics card. And if each of those allocations fail on line 60, 66, and 72, I'm going to alert that a CUDA allocation failed. And then I'm going to copy the memory content of A into the device A array, the memory content of B into the device B array, and then I'm going to invoke the kernel, add kernel, as you see here, which is this function up here. That takes care of adding on your graphics card. So you're going to invoke the add kernel and perform the addition on the device A, device B memory, and submit it onto the device C memory. Once all this process is done, then we will synchronize our device, and then we will copy back the results from device C to pointer C. And if any of these errors happens, we're going to basically deallocate memory units on my CUDA graphics card. And if any of those go through, then I will be good and I'll return the CUDA status. So this is a very simple program. We'll learn about how to do this, so don't be worried if you didn't understand what happened with this program. Essentially what we wanted to know is to test to see if our graphics card is set up, it's working and functional. And from this point on, you should be ready to tackle any kind of programming applications that you have on CUDA graphics cards, or essentially accelerate your programs.